So this is another lesson of the Demystifying Compilers series, continuation of lesson 3, that is the Syntactic Analyzer. Today we'll address the shift-reduce algorithm. So this is the bits in alta velocidade channel, bits in high speed. So in this lesson we will learn how to mount an LR-Automaton and deepen on the shift-reduce bottom-up algorithm. So come with me. So shift-reduce is a bottom-up algorithm. Shift is an operation that gets a token and puts it on the stack. Reduce is an operation that synthesizes a stream of terminals and non-terminals to the left side of its production. We use a stack and an input stream in which both will be changed during the passing. In order to determine what will be the operation performed for a stack and an input token stream, we use the LR-Automaton of the grammar, and we'll explore on the next slide how to construct such automaton for this grammar on our right here. So it's the same as on this slide. So in order to apply the bottom-up shift-reduce algorithm, we must at first construct the LR-Automaton of the grammar of the language. For that, we need to explore at first the concept of closure of a non-terminal. That is a set of involved productions on this non-terminal that are of a token stream with respect to the grammar. So for example, for this production here, program going to var DCLS, we see above a bullet before non-terminal var DCLS. It indicates that we must expand the reachable productions from var DCLS, and they are these two productions here, var DCLS going both to type deck list semicolon var DCLS or to type deck list semicolon. And the bullets are before the non-terminal type. So we keep this process of closure expansion until there are no bullets immediately before non-terminals. That is, when we reach, for instance, a situation where the bullet is in the end of a stream or before a terminal, that is this case here of type going to int float double string, and these are terminals. So all expanded productions will form a state on the LR-Automaton. So with an additional production program dash going to program, there is a state with the following content. So we have this state here that was formed by the closure of this bullet expanding program, and this program has a bullet expanding var DCLS that itself has bullets on these on its two productions before type. So we also have bullets before the productions of type that are int, float, double, and string. And we finish here in this state because these are terminals. So we can see from the state above that there are bullets preceding 7 symbols, terminal and non-terminal, program, var DCLS, type, int, float, double, and string. These symbols will be labels of edges that go out from the state and that advances the position of the bullet on the production, and so on, as it is shown on the left. So we have here our initial state, and these are the symbols that are succeeded by the bullets. So there will be an edge called program, another int, float, double, string, var DCLS, and type. So we keep on doing this process until we reach the whole LR-Automaton, and it is shown on the next slide here. So this is the full automaton that we construct, and for this automaton we will apply our shift-reduce algorithm. So how does the shift-reduce algorithm work? Basically, it starts from the state where there is a program dash going to program. For each state, it checks the current token being analyzed on the input token stream. If the token matches one of the edges going out from the current state, it shifts the token to the stack and advances from the source state to the destination state, traversing the edge that corresponds to that token. If the current state has a bullet in the end of some production, then we must backtrack from right to left throughout the edges and advance on the edge that corresponds to the left side of the production where there was a bullet on the end of the right side. So let's apply our shift-reduce algorithm for this LR-Automaton here. So the algorithm starts at the initial state of the LR-Automaton. The first token of the input is int, that has a corresponding edge going out from our current state. Yes, another important feature is that we will apply this algorithm of shift reduce to this chain here that has an input, a declaration of a variable that is a token, an int token followed by an identifier and followed by a semicolon here, and then we have the final symbol. So we'll apply to this input token stream here our shift reduce algorithm, and of course for this LR-Automaton. So we start on the beginning of we are in our initial state, the one that has program dash going to program, and we see that there is an int going out from input. So what we have to do is to shift, that is to go from this state to this state through this edge here. So we reach this state here. Now it's shifted. So we perform the shift operation. Now we notice that we are in a state that has a bullet in the end of the right side. So we must perform a reduction, replacing terminal int by non-terminal type on the stack, and backtrack through it through int and advance through type, reaching this state here. Now we are in a state where there is an edge label ID and an identifier Z on the input token stream. So we must shift it to the stack and advance through edge ID, reaching this state here. Now we see a bullet on an empty right side on production ASGN going to bullet. So we must perform a reduction, replacing lambda on the stack by ASGN, and backtrack through lambda and advance on ASGN, reaching this state here. We see now a bullet in the end of the right side of production backlist going to ID ASGN. So we must perform another reduction, backtracking through ASGN, then from ID, and then advancing through that list, reaching this state here. Now there are two productions whose bullets precede a semicolon, and we see a semicolon in the beginning of the input token stream. So we perform a shift operation, reaching this state here. Now we see that there is a bullet in the end of the production whose right side is type declist semicolon, and whose left side is var DCLS. So we must perform a triple backtrack from semicolon, then from declist, and then from type, and at last advancing through var DCLS, reaching this state here. We see another bullet in the end of the right side, var DCLS, in the production whose left side is program. So we must backtrack through var DCLS and advance through program, reaching this state here. We are almost there. There is an edge with a dollar ending symbol, so the algorithm accepts the input token stream. So this was an application of the shift reduce algorithm, and we summarize all the operations performed on the next slide. So for the LR-Automaton of the grammar of our program, we apply the shift reduce algorithm and reach this table with these operations here. These are the same operations that we performed during our traversing of the LR-Automaton. So this was our shift reduce algorithm. So in this lesson we learned a little bit more about algorithms that pass programs, saw some issues related to the grammars that are accepted by such algorithms. We saw also a shift reduce algorithm. And on the next lesson we will start seeing semantic analysis, the phase of semantic analysis. So, do you want another algorithm to be explained? Post on the comments. Thank you very much. Subscribe on the channel, like the video, push the little bell such that you receive notifications for my new videos, and make questions and suggestions on the comments. Thank you very much.